When we're graphing reciprocal trig ratios, it's just like graphing any other reciprocal function. So we follow the same guideline. So if I take a look at f of x, the main thing that we want to look for are where the f of x is equal to 0. So in yellow here, I've highlighted the 0, f of x equals 0. We're looking for vertical asymptote in the reciprocal function then. So that's the most important thing. So if I take a look at the sine graph here, and I've got sine x, where there are zeros, I need to make note of these zeros because these zeros are the most important parts. And where there's zeros, we're going to have vertical asymptotes. Okay, so I'm going to draw my vertical asymptote here. And this would be the most important parts that we are trying to establish when we are establishing a reciprocal function. So there it is. When f of x is 0, the reciprocal of 0 is undefined. We're dividing by 0, so we get these asymptotes. So the other part that we'd have to think about is the reciprocal relationship. So I've highlighted that in blue, where f of x is small or less than 1, 1 over f of x becomes a large number. It gets more closer we get to 0, the closer we get to infinity. And where f of x is large, so as we move away from the x-axis, that reciprocal 1 over f of x becomes very small. So if we divide by a large number, we get a very small number. So essentially, as we move away from the x-axis, the reciprocal moves towards, and where the f of x moves towards the x-axis, the reciprocal moves away. The other point is the y value of 1. Okay, and this is called an invariant point. You don't need to remember that terminology, but it's called an invariant point. So that's what I'm going to identify. Okay, so I'm just going to circle that in red. So that's my invariant point. So when I take a look at my graph, where f of x is equal to 1 and negative 1, we end up with invariant points. Okay, so those are my invariant points. So when I sketch my function in, my cosecant function, I'm going to start at 1, and as everything's moving towards 0, so everything moves away from 0 and up along the asymptote. Okay, so again, this one, if we look at 3 pi over 2, the graph's moving from negative 1 towards 0, so the graph then moves, the reciprocal graph must move away from 0 to the asymptotes. So same thing over here. And that's how we get a reciprocal function using those properties. So that's the cosecant graph. It's these U-shaped graphs with asymptotes. We can do the same thing for cosine. Okay, the reciprocal is going to be cosecant. So again, the most important part that we're looking for are the zeros. So we're going to locate the zeros. I've got zeros here, 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 and here. And then drawing in the asymptotes through there, there's vertical asymptotes that go through those zeros. We take the reciprocal of 0, we get these undefined asymptotes. Okay, so there it is. There's our asymptotes. We want to then identify the invariant points at positive 1, negative 1. Okay, these represent invariant points. And then using those invariant points, we're going to start at those invariant points and notice that the graph, the blue graph, all moves down from 1 towards the x-axis. So the reciprocal graphs are all going to move away from the x-axis. And again, we get the same U shape, except our asymptotes are in different positions. So this is our secant function. It looks just like our cosecant function with different asymptotes. Looking at tan x, again, we want to identify the zeros. We want to get our vertical asymptotes through those zeros. Now, as we go to positive and negative infinity, the reciprocal of that is going to be a zero. So as I stretch out that way and this way, that's going to lead towards a zero. So the opposite happens. So those represent the zeros. So I'm going to draw my zeros here. I'm going to have zeros here where the asymptotes were previously. They now represent zero. It's a reciprocal relationship. And then I can draw in the reciprocal relationship. If you want to identify the 1 value and the -1 value at the 45-degree points halfway through the quadrants, you can do that. Okay, that's useful to help you draw. It's not entirely necessary, but these points at 1 and -1 allow us to then draw our graphs a little bit more accurately. It goes through that point, through the zero, through that point, and then follows the asymptotes. Okay, and again, the key are the asymptotes. It's going to follow the asymptotes, go through that y equals 1, the 0, y equals -1, and then follows the asymptote down. So that green graph then represents the cotan function. Okay, that's the reciprocal function of the tan. It looks very much like the tan, except it's kind of going the other way. It's almost like a horizontal reflection.